So the reason why CloudPhysics was founded was this. The data science is everywhere today. Today, if Facebook can predict when your relationships is going to break up. Amazon can ship packages before even you click on the order button. Twitter can predict where the flu outbreaks are happening, and so on and so forth. So the most interesting one out there is, I think a few years ago, Target predicted that some woman was pregnant. The teenage daughter was pregnant at home even before the father knew it, and that became a big controversy. So basically, they found the pregnancy based on their shopping patterns. So this technology exists everywhere, and people have been applying it for consumer behavior prediction. But the irony is, all of this prediction runs in some data center, right? The apps which predicts these things runs in the data center, and there is no prediction available even for the data center itself. So that's the basic premise of on which CloudPhysics was founded. So analytics, it's pretty popular in the business space for the last, I would say, 30 years or so. Analytics is becoming very popular in the monitoring our health, Fitbit, Apple Watch. So it's gaining steam in our personal lives as well. But the analytics on the data center space is pretty much non-existent. So CloudPhysics, I would say, is one of the pioneers in that space. And so that's why the company was founded. So the basic premise is data center has evolved. In the last 10 years, virtualization has transformed the IT industry quite a bit. We all know that. We're all a part of that. We witnessed it. But the IT operations management itself has not evolved. A lot of the IT operations management software out there today are retrofitted. They are legacy tools meant for the age of pre-virtualization, and then people try to retrofit that in the virtualized, more dynamic infrastructure. So along with that comes a lot of problems. Now, all of these tools are very siloed, very tedious. You have to extract data from one place, process it in Excel. And so getting the information that you need to make any decision making is become such a chore that often people don't do it. So the end result is you rely on some complex software, and the software throws you all kind of charts and widgets and whatnot, and it overwhelms you. So it becomes paralyzing, and data is supposed to be liberating, right? Insight's supposed to be liberating, but it ends up being paralyzing. And because of that, it's very difficult to make any decisions that are data-driven. So that's the whole premise of why CloudPhysics was founded. So we are a big data shop, but we don't want to overwhelm you with a lot of data. We want to provide you answers, insights, filter the signal from the noise. Basically, that's what CloudPhysics' mission is. So the solution is very simple. It's basically a virtual appliance that sits in your data center, and it sips information from vCenter. We deliberately call it as sipping because we don't cause any load on vCenter at all. We have done a great length of engineering to make sure that we sip data, that your vCenter doesn't even notice it. That's why the collector, which collects data, we call it as observer, because it just observes data without causing any impact. And the collector sends and streams this data to CloudPhysics platform. And we only collect infrastructure metadata, no personally identifiable information. You don't have to worry about HIPAA compliance or SOX compliance. We don't collect any of this data. Only just collect infrastructure metadata. On top of that, I've been collecting this data from thousands of data centers in the last 3-4 years. And so we have collected over 100 trillion samples to date. And we're collecting at least 180 billion samples on a daily basis. So that's a lot of data that gets ingested. But all of this data is of no use if you can't do analysis, correlation, and use this data for modeling and simulation. So that's what we do. And we also take data not only from customer environment, but also from publicly available sources, such as knowledge base articles, compatibility lists, or anything that we can get from public sources. We take that as well. And then we analyze and we present insights. So it's as simple as that. Collect data, analyze in the cloud, do some magic there, and then show the insights back to you. So that's pretty much the slides I have. And if you guys have any questions before I dive into the demo, I can answer them.
You know, I have a question. One, can you talk a bit about the privacy around this data? That's, you know, when things are hosted and people are giving up their, you know, their data center information to you, they might have some, you know, issues around privacy or corporate, you know, requirements, regulations, things like that. How does that work?
So great question, right? So when I joined CloudPhysics, the very first question I asked the founders is, how is this going to work? Do you expect customers to ship their data to the cloud? I was a skeptic, like many of us were. But I think we are living in an age that cloud is getting increasingly accepted. So that's one thing. So I was a little surprised when I saw many customers that we have spoken. I would say most of our customers had no issues sending their infrastructure metadata to our cloud. And when we explained our security architecture and how we store our data in a multi-tenant environment and in a secure way and in an encrypted fashion, when we explain the technology behind it, we haven't had any issues with our customers. So to answer specifically a question about privacy, all the information that we collect, we anonymize it, we store it in the cloud. We don't expose any information as specific customer information. We don't expose it anywhere, like all the cloud service providers out there. However, we aggregate metrics collectively from thousands of these data centers, and we gather insights. We can identify trends and patterns. That is something we publicly publish. For instance, today morning, we released a blog. I wrote a blog on how Windows 2003 end-of-life event that's coming up next week, how this trend exists in a virtualized infrastructure. How are people using operating systems in virtualized infrastructure? That's a global trend, and that comes from aggregated information from thousands of users. So those kind of information we publish. But as far as the individual users themselves, nobody has access to their data besides themselves. So does that answer your question?
Yes, yeah, absolutely. You also mentioned taking data from knowledge base articles and public sources. What do you mean by that?
So there's a lot of information right now captured in the public media. Like if you go to blogosphere, there's a lot of excellent blog articles, right? And then you go to the forums, there's a lot of healthy discussions out there. And then there's also a lot of information in knowledge base articles from VMware, HP, Dell, IBM. Now, all this information contains some sort of metadata. So when people are talking about an issue, they're talking about a particular ESX version, they're talking about a particular firmware version, device driver version, certain combinations of situations. All of that is basically metadata. So what we do is we capture that metadata along with the knowledge base article information. Then we store it in our cloud. And then we do metadata correlation and mashup with customers' environment so that we can precisely identify which of these issues that has been discussed publicly is relevant to your infrastructure. So right now we're only doing it for vendor-approved content, such as a knowledge base article, but nothing stops us from even doing from blog articles or information that you can find in the forums. So that's what we do. So we also have taken hardware compatibility lists, pricing information for our public clouds. All of this information, right now, we see them as very disjointed. We see them as, hey, that's a content out there. It's not, I don't know how to map it to my environment. So that's the bridge we provide. All the information that you see out there is actually relevant to you, but only relevant in a certain context. and we bring that relevancy there.
Makes sense, makes sense. And for the last question, when you are taking this, knowledge-based articles or customer data, what about false positives? So maybe there's something that works yesterday but not today. How does that play into the equation?
So that's a great question. So false positives are a big pain point for sure. So this is why we actually do human curation. So all the content that we are ingesting into our platform are curated by human beings. So recently we had an incident where the KB article that we were matching for a customer environment was pointing the issue was applicable only to ESX 5.1, but the customer was running 5.5. And the customer said, oh, how could you match this article when my version number is different? And then it turns out the human curator was ingesting the data, really understood the issue, and then he found out that issue was applicable even to 5.5, but the VMware did not update the KB article. But he knew the issue is broad and applies to all versions of ESX, so he overrode what was there in the KB article, and we were able to do more accurate matching. So I think human curation is one important aspect. And the tagging mechanism that we use for matching is super crucial. So I think we have found a way to do accurate matching. Having said that, I'm not guaranteeing that all the matches we do is 100% accurate. So we also learn from user behavior. So in our product, we also have the ability for the users to say whether the matches are correct or whether they are incorrect, whether the issue resolved, whether the recommendations in the KB article resolve those issues. So we capture all of that information as well. So this allows us to improve our accuracy of matching as well.
Perfect, perfect. Okay, that's the questions I have for you now. So, guys, if you have more questions, please use the questions piece of GoToWebinar. And as you can tell, we ask them within context. So feel free to ask away, and we'll get to them. Let's continue along. Demo time, right?
Yep, let's do the demo.
Perfect. This is the best part.
Okay. Actually, let me log out of the app and I'll do the demo login. So as you can see, this is live demo. This is coming from app.cloudphysics.com. I'm going to log in as one of the demo user. And you see our platform is like super snappy. Like you log in instantaneously, you get all the insights. So one of the powerful features of our platform is people can get insights about the data center literally within 15 minutes. And when I say 15 minutes, it's end-to-end time. From the time you sign up on our website to the time you log in and you analyze your infrastructure, everything could be done in 15 minutes. So the way this works is you register on our website. We send a link. The link is for downloading the appliance. The appliance is 400 megabytes download. So if you have a good pipe, you can download it in a few minutes. You deploy it as an OVF or an OVA into your vSphere platform. And then you just give your vCenter credentials. You can just give read-only credentials. And then once you do that, it starts streaming data. The appliance doesn't store anything locally. It just streams data to a cloud. As soon as we receive the first batch of information, you can log in and you can start looking at infrastructure and gain insights. So that is, when we say this to our customers, a lot of customers don't trust us. They say, oh, 15 minutes? Come on, give me a break. No enterprise software gets installed in 15 minutes. And they get really surprised when they actually see the product and how easy to use and how quickly they can gain insights. Anyway, so that's the backdrop of what you need to do before you log into this platform. But let me show you some of the stuff we do. So I talked about taking external data sources. So here's one example of how external data sources is used. So we look at every server out there and we do hardware compatibility checks. And the way we do our compatibility check is by looking at VMware hardware compatibility list, and then we can identify which ones are compatible, which ones are not compatible. We can quickly give you a breakdown of all your ESX builds, and we can also slice and dice your environment by any fashion. So one of the advantages of being a SaaS product is that our observer could work in multiple locations. So you could install and deploy CloudPhysics in different sites, and all of them will send data to our cloud. So you get the unified global view of your infrastructure. And so you don't have to worry about doing VPN to different sites and trying to collate all the information. All of that is taken care for you. So then in our platform, you can select which portion of infrastructure you're interested to analyze and which cluster, and then you can do all sort of checks, compatibility checks. You can do simulation. For instance, the environment right now is pretty simple. It's running 5.1, and you want to see whether this is compatible with ESX 6.0 or ESX 5.5. Those kind of checks are very easy to do. So that's one simple stuff. That's just host inventory, right? It's very basic stuff. We also do this for I/O devices. So the demo environment is very small, as you could see, but in a real customer environment, these tools, power of these tools are really amplified, because when you have hundreds of hosts, keeping track of these hosts across clusters, keeping track of which devices are running on this host, what firmware version they are running, and so on and so forth is really, really tedious to manage. So we have simplified that tremendously. So again, here we look at individual I/O devices, and we can tell which of these devices have compatibility with the ESX host, what is the firmware version you're running, what's the firmware requirements the vendor is insisting. So if the firmware versions that you're running is below the firmware requirement, that's something you need to seriously take into account. You can do simulation. You can even search for machines which contains a particular model name, firmware version. All of that is really easy to search, and you instantly get those results. So that's the basic idea of our platform. Actually, one thing I forgot to mention is before deep diving into this analytics, I didn't explain the concept that we have in our platform. So let me briefly explain this. What you see on the screen is a bunch of these rectangular boxes, is what we call them as cards. And each card is basically an analytical output of a particular aspect of your data center. So you can think of a card like an app on your phone. So each app focuses on a specific task. Each card focuses on a specific aspect of your data center. A collection of these cards, we call them as decks. So you have different decks. And if you want to create your own custom deck, you could create one pretty easily. And you can basically drag and drop anything you want to do into that deck like this, basically. And then you can have your own custom deck. So that's the whole concept there. Okay, so any questions before I go further deep dive into all the capabilities of our platform, because there's a ton of things to showcase.
No questions right now, so please, I have a few of my own, but I'll save those because I have a feeling you're going to get to them. So please continue.
All right, so this is the blog that I was telling you about that we just released today. So we are tracking operating systems running in your environment, and we can tell you which operating system is going to reach end of support in how many days. And then you understand the risk in your infrastructure as well, like what are the total virtual machines, which virtual machines are going to run out of support in 3 months, which are going to run out in 6 months, and so on and so forth. Again, very simple analytics, but it helps you, gives you a very broad overview of your infrastructure so that you can plan accordingly. Instead of reacting to problems, you can get a little bit proactive and fix issues before they occur. So that's one capability. We also have cost calculators for public cloud migration. So the cool thing about this one is Pretty much every customer that we have spoken to has some plans to migrate to the public cloud, or at least they're considering them. And the problem for them is they really don't know how much it's going to cost for them to move their infrastructure to the public cloud. Now, the public cloud vendors have pricing information. The pricing information is a catalog pricing. You really don't know how that catalog applies to your infrastructure. So we built this card where we can look at your infrastructure and we can map your infrastructure to the catalog that is available in the public cloud. And the mappings is what we show here. So the current infrastructure, we mapped it into different types of Amazon catalogs. And we compute the cost for each of these, the lowest price across the entire geographical location that Amazon has the cloud offering. And we calculate the price for 3 year, 1 year, and then we summarize it for you. So this takes a lot of work out from you because you don't have to know which VMs are eligible for migration to the public cloud, which VMs you cannot migrate, we call them as unmatched, and what's the recipe you need to purchase from public cloud and how much it's going to cost. And in case you want to play around with the settings and say, you know what, I want the cost for European Union, or I want to change my storage type. Everything is at your fingertip. You just change things on the fly. It gives you the pricing information. Now, this could be done even for a specific portion of your cluster. You can even do it down to the level of a single VM. So it's that powerful, basically. So that's the whole idea of CloudPhysics is make all this information available at your fingertips so that it becomes very easy for you to make decisions and not having to worry about the tedium involved in collecting, analyzing, all of that. So that's all gone. So now you can focus on your business problems by using the data provided by CloudPhysics.
Makes sense. Makes sense. I do have a question from the audience here, and it goes something like this. These modules seem very similar to certain Microsoft System Center 2012 modules, such as Server Manager, Operations Manager. What is the competitive advantage that CloudPhysics platform provides? And I will add on to that because this is a question I always ask in every podcast and almost all my webinars is why should I look at the CloudPhysics solution versus the competition?
Okay, so there's a great question again. A number of things there. First one is the approach we have taken is very different. So it'll become evident as I show more and more cards. Second is being a SaaS platform, you have to manage nothing. You don't have to maintain a database. You don't have to worry about storage. You don't have to worry about the performance of your management applications. All of that is out of the window. Often I've seen people struggling with maintaining the performance of their operations management software as opposed to the performance of your infrastructure itself. Big technology differentiator is that the data that we collect is stored in our cloud without any rollups. So this means is all the performance data that we collect it at the finest resolution possible, which is 20 seconds in vCenter environment. That's a sampling interval, the finest resolution you can collect. We store them as it is into our cloud indefinitely. We also collect configuration snapshot every 1 hour, and we store them in a cloud indefinitely. So what this allows us to do is look at trends, much longer duration, look at your performance trending at the finest resolution possible. So the analysis that we provide are pretty powerful. So that's one differentiator. Second one is because we have this massive data set from your environment and also from thousands of other data centers, we have developed a lot of simulation modeling techniques that provides you a kind of insights that is not possible with any on-prem software out there today. So that again will become evident as we go through some of these cards. So those are I would say the major differences. As far as the solutions themselves concerned, yes, there could be overlap with the other tools because they're all trying to solve the basic problems the customer has, which is managing your servers, keeping the uptime, improving performance, capacity planning. Those are very standard problems the customer needs. But the approach we have taken has yielded insights is very different and very accurate, I would say, compared to the products out there. So one example I have had customers tell us is because other tools roll up data, they really can't spot which VMs are truly idle because all the spikes in your CPU utilization get smoothened out over time, and they really can't understand the patterns of those VMs, and therefore the other tools overestimate or underestimate your capacity needs. And so we don't run into those problems. Second thing is all of the tools are very reactive in nature. They look at problems today and say, this is the problem, go fix it. They don't look at what's the underlying pattern in your infrastructure. What's happening in the last 6 months in a recurring fashion that you are not aware of, that you should go fix it. If you fix the underlying structural issues, then many of these recurring problems won't be recurring anymore. So that's another differentiation that we have in our product.
Sounds great.
Does it make sense?
It makes total sense to me, but I'll throw it back at the person who asked that question. If we weren't able to answer that, I think you did a great job. Please let us know. Just ask a follow-up question, and of course that goes for anyone. If you have any questions, please use the questions piece of GoToWebinar, and we will get to them. So please continue.
Yeah, let me show a demonstration of what I just told, right? I mean, it's easy to say it in words than just showing you the product, but let me show what I just said. So here is a problem, a very complex problem, which I would say no on-prem tool out there resolves this today. The problem is storage is a shared infrastructure in virtualized environment. Because it's a shared infrastructure, you cannot go to an individual host and look at what's the total cumulative throughput that happens on a shared storage. You have to go to the storage area backend, or you have to stitch this information manually. Now, the problem with going to the storage area backend is the storage area backend does not have information about your virtual machines. All it sees is a blended I/O. I/Os from all the virtual machines at the LUN level, and it doesn't have the granularity of the information that you need for troubleshooting a problem. So what we do is we look at every virtual machine. We know where these virtual machines are mapped, which data store they are mapped to. We look at the I/Os issued by all these virtual machines. So we can construct what's the cumulative I/O you're pushing to a particular data store. Not only that, once we identify that, we can also see if there's any overlap. If two or more virtual machines are issuing I/O at the same exact time, and if they are, then those virtual machines are contending for resources, potentially contending for resources. So next thing we do is, okay, is there an overlap? And if there's an overlap, we're also going to check if this overlap causes any latency impact. And if there is a latency impact, we also automatically do root cause analysis and tell you which VM was the culprit and which VM was a victim. So all of this is automatically done. And this is a really complicated big data problem because we're talking about correlation of thousands of VMs, thousands of metrics against each other and finding out if there are any patterns there and so on and so forth. So the screen that you see on front of you is the contention timeline in the last 24 hours. All the skyscrapers you see are basically the number of contention that has happened. For a given data store, for every contention spot is highlighted into the ping zones, and for each of the ping zones, we automatically identify which VMs are culprits and which VMs are victims. Now, there's one key thing I want to highlight here, which most tools have issues with. What we are tracking here is issues, not symptoms. Tools out there today track symptoms. They track if your latency is really high, they'll throw you an alarm. If your throughput is really high, they'll throw you an alarm. But those are symptoms, and there could be a lot of false positives. So case and example is, in this case, the throughput is really low, but we still mark that as a contention zone. Why the throughput is low? The throughput is low because there is high contention, and therefore the VM could not push the throughput. But if you switch to latency view, you will see a spike there. And there also would be cases where your throughput could be high, and we won't mark it as a contention zone because the throughput is high, but there is no real contention. It's just one VM issuing all the IOs to the data store. So we are really smart about detecting issues and not symptoms. So that makes this analysis much, much more powerful, because once you look at this analysis, you know the patterns. You see the contention patterns in your data store, in your infrastructure, and you also know for every contention which VM is culprit. And if you see the same VM as culprits on a recurring basis, basically you need to isolate the culprit VM so that it does not interfere with other VMs. So this is a kind of analysis, trending-based analysis, correlation-based analysis, requires a platform which is truly a big data platform. It's very difficult to do this on-prem. So that's the key differentiation of our product compared to the other products out there.
Perfect, perfect. I put myself on mute, and sometimes I struggle to get off of mute.
No problems.
That is great. That is great. So, yeah, please continue.
Yeah, so the contention also, we have ability to like choose your time periods. We automatically narrow down which data stores are contention. If you look at the metrics that we show on the right-hand side, they also change based on the time period chosen. So you can also identify, okay, what's the throughput I pushed between 10 p.m. and 6 a.m. yesterday night, all kind of issues. So when we show this to our customers, a lot of customers identify things that they are not even aware of. So one popular thing is many customers don't know when their backup window is kicking in for different portion of their infrastructure and how that impacts contention. So they come into this card, they sort the contention timeline, and they see patterns here. Oh, all the VMs experience contention at one particular time period, and often that ends up being their backup period. And then we also highlight them any metric that we think is anomalous compared to the global data set that CloudPhysics has, compared to what you have in your infrastructure. So this is very interesting for them is because sometimes your baseline in your infrastructure could be way off, and you don't want to start off with a bad baseline and use that as a reference point, which is what many tools do. They use your infrastructure as a baseline and see if you're deviating from the baseline. What we do is our baseline is the global data set. So when we see a latency like 781 milliseconds is extremely high, we highlight it because this kind of peak latency happens once in a while, but only happens for 5% of the CloudPhysics population. So this is not a common event. So we highlight that. So there, yeah. So that's just the power of our platform in terms of analysis. It's all pre-baked, done in the cloud, and you can access it from a lightweight browser at any point, and all the information is at your fingertips, essentially.
Perfect, perfect. What about
Let me switch gears.
I was just going to ask you, show us the storage stuff.
Sure. So one of the things we found out from our thousands of data centers that we have access, data access is storage space gets wasted in a VMware environment like no other. And that's no wonder why there are so many storage companies out there in the VMware ecosystem. The reason for this is just like people are worried about VM proliferation, how you're wasting CPU resources and memory resources by spawning a lot of virtual machines. The problem is more intense from a storage point of view, because even if you have a lot of VMs and the VMs are idle, they're not consuming much CPU resources, and even memory resources could be swapped out. But storage resource on the other end is permanently is wasted. And often people power off the VM and forget about that. Often people delete the VM but don't, or unregister the VM and they forget about that. So they don't really go and clean up the data. Second thing is snapshots. A lot of customers use snapshots, and snapshots can get very messy. You can create snapshots, unlimited number of snapshots. They grow in size. It's hard to track them, and you don't know how much space they're wasted. Third one is thin provisioning versus thick provisioning. So we do a bunch of analytics around your space usage, and we can estimate how much gigabytes or terabytes or petabytes of storage you can save in your infrastructure. So let me start with snapshots gone well. So this one looks at all the snapshots in your infrastructure, how much space you're currently consuming, when the snapshot was created, what's the growth rate of the snapshot, whether a snapshot is being actively used or unused. All of that is something we do analysis on by tracking the snapshots usage pattern over time, and then we can show you how much space we can reclaim. We do look at VM's power state and track if a VM is ever being powered on back. So a lot of times the infrastructure guys, if they doubt if a VM is not being used, all they do is switch it off and hope nobody complains. And if nobody complains, it means that nobody's using it. So you can track how long the VM has been switched off and not used, and how much space you can reclaim from deleting those VMs. We can also do a simulation of converting your existing thick virtual disk into thin virtual disk and estimate how much space you can reclaim from doing that conversion. And so this is a big savings, and it's a lot of surprise for a lot of customers. So a lot of customers use thick provisioning traditionally because VMware has been recommending thick provisioning in the past, and it's not the case anymore. For performance reasons, the performance of thin provision virtual disk is same as thick now, so there's no difference. But the space savings you can get is tremendous. So a lot of newer storage arrays have support for thin provisioning, but the older ones don't. So if you have one of the older arrays and you don't have thin provisioning, it makes a lot of sense to use thin provisioning, and you can reclaim a tremendous amount of disk space. So that's the analysis we provide. And also the other thing people are not aware of is if you already have a thin provision virtual disk, the thin provision virtual disk will inflate over time, and it won't automatically deflate. And so we also estimate how much space you can reclaim by reconverting an existing thin virtual disk back into thin virtual disk to reclaim the inflated disk space. That's, we call it dead space. So anyway, so there's a lot of interesting analysis you can do. You can slice and dice this data set. You can even look at VMs which has unpartitioned space. So this is another common problem. A VM requests a lot of disk space, and sometimes you don't even partition them. All the space allocated to them, and so you're wasting those disk space. So you can get all of those details as well.
That's perfect. I have a quick question for you. Is now a good time?
Yeah, sure.
Perfect. So a question from the audience here. On the performance front, does the performance, if I could see this properly, on the performance front, does the platform convert the insights into actionable recommendations for load balancing to result in better performance?
Yes, we do have insights in the user interface. Right now we don't show it, but we're going to update that pretty soon. So basically for every zone here, the pink zone that you see is an area of concern. And we break this concern into something called as need attention and something that is noteworthy. So let's focus on need attention. Need attention are the ones where your contention is so severe that you have severe impact and latency. So for instance, if this West Epic VM is a culprit VM in these time periods, all these different time periods. In some cases it's a different VM, but let's say West Epic is the culprit. So usually culprit VMs, if they become a recurring pattern, then you need to isolate them into its own data store. So that's the basic recommendation is. The other thing we are working on is long-term trending of these. If you see patterns as like, hey, West Epic is a contender, but only between 7 p.m. and 8 p.m. in your infrastructure, that's something we can surface up. So then you know what? maybe that VM is better placed with some other VMs which does not have any workload between 7 p.m. and 8 p.m. So that's the kind of insights we will be bringing up, not in the product today, but it's going to come up pretty soon. But right now, our recommendations are based on what you see in the last 24-hour window. But we do track of information beyond 24 hours.
Perfect, perfect. And then, of course, please let me know if that answered the questions. And if not, then ask a follow-up question. Are we going to move to health checks or more to show within storage?
Storage is a couple of things. One other thing I want to show is our predictive ability to estimate the risk of a data store filling up. So let me walk you through that. That's a pretty cool feature that we have. Essentially what we do is for every data store that's out there, we compute the risk for the data store to fill up in 1 week, in 1 month, and in 1 year. And the way we do it is by modeling. So the data stores in the VMware environments are a little tricky. Why they're tricky is you could provision a bunch of VMs together, and that space usage is going to rise up pretty quickly. Or you can delete a bunch of VMs or storage vMotion in those VMs. Your space usage is going to dip down tremendously. So it's very volatile in nature. There is no one single sustainable trend that you can find. So if you often look at the space usage patterns in many of these environments, they'll be very spiky in nature. They don't have a steady increase. So modeling these guys based on the current growth rate is often ends up being the wrong projection. So what we have done is we developed a modeling technique where we look at all the past historical events and we apply those past historical events in a simulation and predict what might be the future look like. And if we run the simulation thousands of times and we find what's the probability of your data store filling up based on the past historical events. And we compute the probability risk, and if the risk is about 75%, and if the risk predicts that the event will happen within 1 week, we actually notify you via email 1 week in advance, indicating which data stores might run out of space. Even though their current free space could be in terabytes, based on the modeling, if the model predicts it's going to run out of space, we can predict it in advance. And this is actually very, very accurate. We have seen a lot of customers who are very surprised by what we're able to detect. So that's one thing we have in the product today. We do this for data stores. We also do this for guest partitions. We apply the same modeling technique for individual guest partitions, and we can predict what's the risk level for this guest to fill up. So for instance, this particular partition, low risk in 1 week, but very high risk in 1 month.
Perfect. Very cool.
Okay, so I think we got 10 minutes, so let me quickly walk through a bunch of health checks we do. So nice thing about our platform is we can programmatically do a lot of checks in automatic fashion as your environment changes. So you don't have to run health checks on a quarterly basis or a semi-annual basis. We run it for you all the time. So for instance, we can look at your tool status, we can identify which virtual machines tools upgrade. Very simple check, but very useful thing to do. We can do health checks on a HA cluster and identify which settings are not there. We give you prescriptive recommendations why you have to search certain things and why you haven't set that. We do this thing for DRS clusters. So you can say which DRS clusters are configured correctly, which ones are not, why certain settings needs to be there. We do your NTP checks. We can find out if your NTP policies are consistent, whether the status is running or not running. We do check on your virtual hardware, and we can identify if you have any device attached to the virtual machine that you shouldn't be attached to, which prevents vMotion. What is the distribution of your virtual hardware version? And we talked about knowledge base advisor, so let me also show you that. So we can look at KB articles published in different time frames, and we can tell you which of these KB articles are applicable to which machine in your infrastructure. It could be a VM, it could be a host, and you can read more about the KB article, and you can also give feedback to us if it's fixed the problem or not. You can also use this as a troubleshooting tool. So if you had an issue with a particular host, you can type in the host name, and we automatically will show all the KB articles applicable to that particular host. And you can also type in the symptoms, and then you will narrow it down to the KB articles that causes that particular issue.
Very cool.
So that's on the health check. Yeah, so this is just a small flavor of what we do. We have a lot more content that you can go to the card store, and there is a community of CloudPhysics users who have developed a bunch of checks. For example, somebody has written a check for Heartbleed vulnerability, cluster settings, so many of them, and it's very easy to add them. You can just click on add to my cards, and then you can go and you can do the checks for yourself. Yeah, so there's a whole bunch of cards that you can run and do health checks. But I want to focus on one item that I didn't get a chance to talk about, which is our card builder. So this is your custom drag and drop reporting tool. And people use this not as a reporting tool, but also as a tool for finding issues, finding a needle in the haystack, and so on. So an example would be you want to find VMs with, you're looking for VMs with a particular characteristic, maybe VMs which runs Windows Server 2003, and you want to see whether they are powered on. You don't want to power them on maybe after the end of life date. So you can put a filter and say it should be powered on. And first you can access how many VMs you have. So you find it a bunch of VMs. And you want to see how much disk space they're currently using. So you can look at VM disk capacity, and you know how much space they're using right now. Or you can even look at which data store they're running, and what's the free space on the data store. So as you could see, all this query that I'm creating, like ad hoc queries, you can run it anytime on our cloud, and this is not impacting your vCenter, and you don't have to write any scripting. And once you've constructed a query, the view that you find is very useful, you can of course do search. You can then save it as a card, and you can pin it to your deck. And once you do that, you can also download the content as a CSV file. So basically, this eliminates the need for PowerShell scripting for 90% of the cases. So this is a really, really powerful tool. Basically, a lot of our customers love this tool, absolutely love this tool.
No, that's very, very powerful.
It is very powerful. So the one thing that I showed you right now is not only a drag and drop VM properties, but also drag and drop the data store property, and it automatically knows that which data store you're talking about. We're talking about the data store where this VM is running. So you can do the same thing also if you know where this VM's host is running, which host this VM is running, you just drag host name, and then we automatically know that you're talking about the host where this VM is running.
Sure. Very cool, very cool. Hey, you had mentioned, sort of briefly said, it doesn't cost a lot on your server because it's running outside. So that makes me ask, what type of overhead does CloudPhysics bring to my environment?
So I mentioned this in the beginning of the talk that the observer appliance that we install to collect data from an environment literally sips data from vCenter. So you don't see that causing any impact at all in your vCenter. Even in the really large infrastructure, we have near zero impact. The primary reason is the way we collect model is we don't collect everything in one batch. We slowly stream it, and therefore you don't see the load on vCenter. We don't need any performance data, performance stats level, stats collection level changes in vCenter. Many tools require you to change the stats collection level. We don't need it because we collect real-time stats. So that also reduces the impact on your vCenter tremendously.
Perfect, perfect. Offline version, everything is hosted. Do you have the concept of an offline version? Does it matter? Or offline, I mean like on-prem, excuse me.
We don't have an on-prem version, and we are a pure SaaS model at this point.
Makes sense, makes sense. And I don't see a problem. And the other thing I wanted you to discuss while we just have a couple more minutes, and we have a couple questions from the audience, so let's make sure we save time for that. But you have a free version also. And can you talk about the free version? What's the differences between the free and of course, the premium version and things like that?
Sure, absolutely. So the premium version, basically, you get everything. You get the full set of decks. You get the card builder. You get access to card store. Pretty much no limits, right? Free edition, on the other hand, is a limited set of cards you get, and starting this month, we are starting next month. Sorry, starting July, we are rotating cards on a monthly basis. So every month you would see different set of cards promoted to the free edition, and next month it's going to change. So that's our model basically. But other features like card builder and the other cards which are not in the free edition won't be accessible for you. So that's the difference.
Makes sense. And if somebody wants to download the free version, it really gives them a good insight into, putting this into their environment and what it gives, and then just wets their whistle to have more, I imagine. So,
yes, absolutely. So currently the ones you labeled as free are available in the free edition, but again, it's going to change month by month. But you'll get a very good idea of what we offer in the free edition. We also have a premium trial. So if you're interested to try out the full product, you can reach our team and they will set up a time trial, so maybe a 15-day trial, and you can explore the full set of features in that 15-day period.
Perfect. Can you talk a little about the caching services? This is a question from the audience. Can you talk a little bit about the caching services in the infrastructure planning?
Sure. So SSD caching has been becoming very popular these days. In the last 2 years, many companies have been providing solutions around using SSDs on your host as a caching device. But the problem is not all workloads benefit from SSD caching. So we developed an analytical simulation platform where we can observe your existing IOs from your virtual machines, and we can estimate whether a particular virtual machine will benefit from SSD or not. And also we can predict what is the SSD size it needs to achieve a reduction in 2x reduction in latency or a 3x reduction in latency. So we can do this complete analysis for you even before you purchase the solution. So that is the biggest draw of this service. This is completely automated at our end. And so all you have to do is install our product and then notify us. So you just click on this card and you just email us saying, hey, start observing my environment between this date and that date. And usually people run it for 2 weeks to capture the full set of workloads. And we monitor the environment for 2 weeks. We send the data to our analysis platform, and then we produce a report, and then we'll send it back to you. The report will contain a list of VMs which will benefit from SSD, what reduction in latency you would expect, and what is the SSD cache size you need for those VMs.
Perfect, perfect. And we are right at the top of the hour. If anybody has any additional questions, please use the questions piece of GoToWebinar, and we'll get to those right now. If not, we'll go ahead and probably call this thing a webinar. So, but before we do that, I want to thank everyone for attending. And I have one more question for you, Krishna, and that is if somebody wants to learn more, what do they need to do? It's always my last question, right? They just go to the website, I guess is the answer to that one.
I
But I
think
heard
the
that.
website has some content. We also have a YouTube channel. There's a bunch of videos on YouTube channel. You can take a look at that as well. And I think our product is pretty easy to play with. So if you have a lab environment or even a production environment, you can just put it because this has no impact on your production environment. And worst case, if you're really worried about it, you can just switch off the appliance and you'll be fine. So I would say the best way to learn the product is just to play with it.
Yeah, that's always the case. And like you said, it's almost a no-touch type of solution. So there's no real
Yeah.
harm. But yeah, of course, people are, change management's important, right? So, you can throw it in a lab or what have you. But, get your hands on this thing, download it. If anything, just download the free version and get a feel
Yeah,
for
and it doesn't take much time unlike other products. So it's a really low cost way of testing out the product. A lot of customers ask us for a demo account access, and I will tell them it's far easier for you to deploy it on your own and see your real data than the demo data because that will give you a lot of insights about your infrastructure that you may not even be aware of. Um, so I think that's the best way to go.
Perfect, perfect. And if you want to see demo data, just watch the videos on YouTube. I've actually watched a lot of those, and it's good stuff. So on that note, guys out there watching, guys and gals out there watching, I appreciate your time today. Please check out this solution, install it in your own environment, and let me know what you think of it. And of course, Krishna, thank you so much for taking the time to do this. It's amazing how time flies, and an hour, and I can't believe it's been an hour already. So I really, really appreciate this. I enjoyed it. I learned something too, which is always my favorite part of these webinars or my podcasts that I do. I always say I'm an attendee also, so I appreciate your time today. Of course, we have recorded this, so I'll get this posted to DABCC here in the next few days, and we'll also get you an email out with a link to all that. So if you want to share it with a friend or what have you, please feel free. If you enjoyed it, definitely tweet about it. Just go to Twitter right now and say, hey, we really enjoyed the cloud physics solution in the DABCC webinar, and I'd appreciate that. Always share the love, right? And but most important, Krishna, thank you so much for taking the time to show the solution today. Like I said, I really enjoyed it. I'll go ahead and
Thanks,
give you
Doug.
the last word, and we'll call it a webinar.
Thanks, Doug. It was my pleasure to be in this webinar, and thanks for hosting me. And I really enjoyed the questions, and I really enjoyed showing the product to the folks.
Absolutely. Okay, guys, thank you so much, and I'll let you get on with your day. Thanks, everybody.
Thanks.